Hey guys, welcome to Unit 2. This is video 2.1. We're going to talk about the history of the atom. This should be kind of a brief overview for you from the work that you've done in lab. So let's just dive right in. The atom, there's kind of three main points that we want to remember with the atom. The first is that it's the basic building block of matter. Okay, number two is it cannot be broken down any further. And number three is that it's a single unit. Oops, spelled that wrong. Single unit of an element. All right, so we're going to talk about like the main guys that had a big part in it. There are a lot more than just these 4 or 5, so just keep that in mind. But we're going to start it off with Dalton in the early 1800s. He's known as the founder of the atomic theory. Now, you don't have to memorize these 4 postulates per se, guys, but make sure you're aware of them. Most of them are outdated. With newer technology, we've disproved those. The one you really want to make sure you know and are aware of is number 4. That kind of leads to the conservation of matter and mass, which we'll talk about. But his theory, all right, is a lot of times known as the Cannonball Theory or model, where you basically have an atom that just looks like a cannonball. Okay. 2 things, it's spherical and it's a uniform density. Okay, so there's kind of the main highlights. About 100 years later, we move to a guy named J.J. Thompson. There's a separate video in this unit in the Google Classroom, guys, so check it out, watch it. It's a cool, quick 2-minute video. I wish I could do it for you in person, but I don't have the power source for it. But basically, he used a cathode ray tube with a charged electrical field. So he put a positive or negative charge in there. The cathode ray was deflected, and that's the key there, is deflected by the negative electrode. Okay, so if it was deflected or repelled by the negative electrode, that means it was attracted or it went toward the positive electrode. Okay. Because of this, he discovered the subatomic particle called the electron. All right, so that's his claim to fame, is that he is the discoverer of the electron. Okay. He noticed that it was small and that it's negatively charged. So now we're starting to get a more like a fuller understanding of what an atom looks like. Still was spherical, more or less. Okay, and that's what this picture over here to the right is describing, where it was mostly positive. Everything you see the red in the picture is positive, and then the blue dots are negative electrons. Okay, this was known as the Plum pudding model. You might be thinking, what in the world is plum pudding? You can look it up, but essentially, guys, it's kind of like tapioca pudding, where you've got the pudding pieces and you've got little bits of rice in there. That's kind of the idea that, hey, you've got this positive piece that's most of everything, but then there's little specks all throughout mixed in there that would be the electrons. So you have that positive pudding, quote unquote, and then you've got negative electrons that are embedded. Okay, so continue along. About 15 years later, the next major guy comes along. His name is Ernest Rutherford. All right, he conducted what is famously known as the gold foil experiment. Okay, where he bombarded a thin piece of foil, gold foil, hence the name, with a positive stream of alpha particles. Alpha particles are just helium atoms. We will talk more about those at the end of the year in our nuclear unit. Okay. but they're positive. So he took all these positives and he shot it through there. He didn't expect the results that he found. They all, or most all, of the alpha particles passed straight through the foil. Okay, most passed through, but some were deflected, and that's what this diagram is showing. So you've got this main line here. I'm going to try to color it in purple. Okay, the main line is most of them passing through, and then you can see some arrows where they are being deflected. So this conclusion led to what's called the nuclear theory / model. Okay, now the nucleus is born. So it's no longer just a round sphere. Okay, the atom is mostly empty space. At the center of the atom is a dense positive core. That is called the nucleus. Okay, you guys are probably well familiar with that. So his experiment showed us that, hey, it's mostly empty space. We have a nucleus now, and it did not give us any information about the electrons other that they were located outside of said nucleus. So a few years later, Niels Bohr comes along. He does a little bit more, goes a little bit deeper with electrons, and he builds this what's called the planetary model. So if you look at the picture at the bottom of the page, right, that's probably what you're familiar with, where you've got this small circle, that's the nucleus, and you've got these orbital rings around there. And that worked great for hydrogen, but that was the only atom that it actually works well for. But we use it as a visual representation of the atom, right? So it helps us kind of conceptualize it in our head. He said that electrons will travel around the nucleus in well-defined paths called orbits, like planets do, okay? Electrons in different orbits possess different amounts of energy. Okay, absorbing or gaining a certain amount of energy causes electrons to jump to a higher energy level. Or to what's called an excited state. So we're going to do a lab. We're going to do a couple different things where we're going to show this. Okay. Now, once those excited electrons emit or lose a certain amount of energy, it causes the electrons to fall back to a lower energy level. Or the ground state. Okay, we will talk more about these two states later in this unit. Okay, now that's important to note, guys, that this energy that they release, this is the same amount that was gained originally. Okay, so they emit the same amount of energy that they gained to begin with. So, continuing on kind of where we're at today, guys, this is the wave mechanical or cloud model. It's what we have today, where electrons have distinct amounts of energy and they move in areas called orbits. Orbitals. Okay? An orbital is just an area of high probability for finding an electron. All right, so it's our best guess as to where they actually are. It doesn't have to necessarily be a circular path. It could be zigzag a little bit. So this is developed after the famous discovery that energy can behave both as waves and particles. That was Einstein's, some of his work. Many scientists, though, more than what I've listed here, have contributed to this theory using X-ray diffraction, which we're not going to even really talk about, but that's the technique that they use. So guys, that's been a brief history of the atom, kind of to where we are today. So go ahead and practice, and I'll see you in the next video.